in one scheme, what is the women percentage and the child percentage share in the from each district. Government is generating the data as well. So at the end of year 2000 March 22, we will send the data to the government. Let's say in government scheme wise, what is the percentage share received by to the beneficiaries, male and female, for each scheme. So these are to there. Regarding career point of view, now the boom is online data, online courses, and online everything is online in government jobs as well and in private jobs as well. So those people who are much more familiar with the computers, or they have BSc computers as well, you can turn to the direct coding or programming as well. Or if you have interest, you can do the some additional private courses as well and improve your analytical and soft skills. Cloud computing is there, data and content management also there, metadata, big data, Hadoop. What is metadata? Metadata is data for data. Let's say, simple, we can consider our example. One company is there with their 1,000 employees. In the 1,000 employees, database of fields are there: name, gender, their salary, their date of joining, date of retirement, all our details are there. So if we have to collect this type of all company data, we need to focus how, if we are preparing that data, what are the contents are required, what is the test length, what is the unit of that data, gender we can consider as a male and female. So the 2 space character or 1 space character required, or much more character. So these types of the data is called as a metadata. So if that metadata is proper one, then we can generate, or then we can get the data in a proper format. Otherwise, data validation checks may require, data may not be clear, or data have some bugs as well. To clear that data, if your master frame or database is much more clear with all their definitions, all their requirements, so it will be the good as well. So there are lot many institutes as well, prominent institute, who run the online courses which are paid for this pandemic situations as well. They are running data warehousing, data management, customer analysis, cloud computing also, but much more there. So here directly role of statistician is related to the data. There are software engineers, but we can analyze the data, or before validating ETL data, we require that statistician here as well. In market research or marketing research, it's a challenging job as well. And for the students as well, this actually opportunity, I'm showing some few opportunities collected few days back. Especially it's on WhatsApp, someone sent me. Date is over, but 25th June 2021 notification, internship program for Sansad was there. So of course, really it's a good opportunity as well. Those who have the soft skills, much more strong soft skill, and ready to relocate for Delhi for some time. So these types of opportunities are there. Niti Aayog also requires some data. Niti Aayog also requires some candidates as well. So that if you look for to the future, so the internship in Sansad, Niti Aayog, or Aadhaar card, UID, so in that you will get the job as well. There are few opportunities as well. I will share one thing. In that Yashada Institute Pune, here the Microsoft all Excel files are there. I will share with this data with the Manoj. You can get it from him. So all the Excel data, all the all advanced applications are mentioned in this Excel site as well. So especially it's for to the newcomers and beginners who wish to career in Excel as well. So for this required. Looking at to the list 14 to 15 years, general Maya opinion and HR opinion also. Here some statistical statement is also there. As many as 25 to 30% of HR say one of the reason they made the bad hire was because only they struggled to find a qualified candidate. Hello.
Yes, sir.
Yes. This statement is because, ma'am, I'm audible?
Yes, you are audible, but your sharing has stopped. You have stopped it.
Yes, yes.
Okay.
Yeah. Basically, this statement is because we cannot, for getting a job, some killing instinct is required properly. Uh, our jobs may be stolen by some other expertise who are in expert in soft skill or some other as well. But basically, those who have a strong statistical background may present and may be in the mainstream of data, because once the data is generation is completed, we cannot change the data and we cannot uh, change the result as well. That time garbage in and garbage out, it was there. So simply our role is much more important. I strongly recommended for to the corporate as well, for to the government as well, and for the, but you must find your own job in a proper way as per your liking and as per your personality types. Now we will talk about to the government jobs. Hello. Yeah. Here the Directorate of Economics and Statistics website is there. It's a website. His name is mahades.com. In Mahades, there are recruitment. It's an old advertise, but I am sharing this one because sir told me actually it's a give some organization structure detail as well. Research assistant is a key post for any district statistical officer and at to the district planning office as well, or at divisional or state department as well. It's a basic step uh, after statistical assistant. Statistical assistant is very lowest post, and I do not suggest directly go to the statistical assistant post, but at least from RA and above you can start your career. Then second post is the deputy director, research officer. Research officer is gazetted post. It's gazetted post in DES as well. There are a lot many opportunities you can find through MPSC. Second thing is that health department have a lot of research officers post, health department. And third is Jilla Parishad Vistar Adhikari as well. But and last is BMC. Few days back in 2018 or 19, BMC also declared some advertisement for this post as well. So there are other central jobs as well through the central agencies as well, NSS and census, DES also there. There are some institute as well in Parel, some reproductive units are there. So there are also some contractual jobs. Indian International Institute of Population Science, OND, IIPS. There also some raise some field work job as well, contractual jobs. And one more thing I want to share that since approximately 8 to 10 months, I am in Konkan region. In Konkan region, qualified candidates are still here crisis. If you find a good position as well, and in government sector as well, contractual jobs are also present in Konkan division as well. Here, lot many crises are there. They don't get the proper candidates as well. In especially health department, now the health is also boom. So this time you can concentrate onto the boom as well. I wish to mention one thing in medical research. My batchmate Prashant Bhandarkar, who is currently working in a Bhabha Atomic Research Center, Mumbai, who has published, I suppose, more than 20 research papers. He has doing excellent role in medical research. So those who have the soft skill, technical writing skills, medical research as well. it's also in demand. Now we'll just mention in district planning committee. In district planning committee, approximately here we can run approximately 70 to 75 schemes for the district. One major section is that Jilla Parishad and another is that state government offices. For state government offices, for each and every scheme, government publish government resolution, especially the planning department and the concerned department as well. Let's say some veterinary department or some other water supply or some municipal corporations as well. So for each and every scheme, their structure is defined one. Who will propose, put up the proposal, to whom we can present it to the proposal. Then let's say we have received some proposals, we can list it out and present it to the district planning committee and our honorable guardian ministers as well through the collector sir. All the district planning committee funds here include the district planning committee funds, MP LAD fund, member of parliament, honorable member of legislative assembly as well, Andar, and hill area development program, some special funds as well, some minority fund as well, or some other funds are there. So all the funds are here gathered in district planning committee, and as per to the proposals we will allocate, and once the proposal is submitted by to the agencies, administrative approval, prashaskin manyata, we can put up for to the district collector sir, and collector or CEO will publish its administrative approval. At that time, as per to the fund demand, 10, 20, 30, 40% or sometimes 100% as well, fund released by to the treasury officers. Agency do the work by tenders or as per to the procedures, and after completion of that work, UC and CC submission through the proper channel. Once that done, this remaining payment will be given to the concerned office after the inspection or field visit. Here, our in Nandurbar district, all the district planning committee members, I suppose there are our, I'm very happy to say that Vijay Shinde, Yogendra Chaudhary, Nirmal, Rahul Pawar, all of there, and all are from NMU as well. And one more thing, Dhule district planning committee officer is DPO is Mamta Hatkar, who is also my batchmate, who is working in a DPO Dhule collector office. Yatin is also doing wonderful job in from our first batch. Hemant Ahire, who was also my batchmate in government sector, who is also pass out of first or second batch from NMU, Kavitri Bainabai Chaudhary NMU. आता नाव थोडं चेंज झालेलं आहे म्हणा, त्यामुळे थोडं आधी हां, आणि DPC चे रोल मॉडेल्स आहेत. सो दीज आर टू दी हिरोज और पास आउट्स फ्रॉम आवर इन्स्टिट्यूट इन मार्केट रिसर्च ॲज वेल. हां, हा थोडं टॉपिक वेगळा आहे, आपण नंतर बोलूया. So here in government sector, I suggest some students may study all the government GR, what is the procedure for the district planning committee, or how the data is produced, or what type of government financial transactions, how they given to the agencies. So these are really high learnability is required, because this work is fit in which scheme is really quite difficult task in the early days. So and definitely through MPSC and other recruitments, our future students will be here. All the best to you as well, and definitely we will see you from this offices, from this board or from this from our university, definitely you will be in days as well. Our Sagar Bagul is one of our my batchmate also, who is working in census offices. There are a lot many others central government jobs too. Due to pandemic, direct government jobs are not directly coming, but after some time, advertise may open. And one more thing here, I will share one head department of government of Maharashtra, especially the NRHM section, National Rural Health Mission or National Health Mission, where the statisticians are required. Ads are published in last 4-5 months or 6 months in various districts as well, in divisional office, in state offices, and in district offices as well. Especially with the tracking of data, patient enter, patient are under observation, and patients who are completed their treatment or that sometimes dates as well. So that this statistics of data as basically this is a statistician role. So no one can direct data entry person is not responsible, because this data is much more sensitive as well. So the various districts or various civil surgeons face the manpower crunch, resource crunch issue as well. So to please note that as well. If you have caliber, and there is no type of COVID pandemic risk as well, because you are interacting with data, not with the patient. Civil hospitals and Jilla Parishads, who have the health department section, is a completely different one. And this job for the beginners is also good one. Earlier, I had worked with the evaluation section as well. Evaluation means scheme evaluation section. For the state, all over the states, we have the district statistical officers. So regarding that, any scheme evaluation was one of the critical tasks for post implementation of a scheme. So post implementation, or if those schemes are running in all other districts, so we did that time though we did for approximately 18 to 20 schemes. We completed its report regarding the scheme evaluation report as well. So it's also one of the good job as well. I spent more than 4.5 years in Mantralaya only for the scheme evaluation section as well. When I was in a tribal development department, we did some cloud computing work. Basically what happened, tribal development department has approximately 30 to 40 websites are there. Some vendors came and they prepared the separate websites for the various small schemes. So once our Sanjay Meena sir, who identified that one and raised that issue, and after government permission, we purchased some state government's cloud as well. All the websites, sometimes websites are merged in the data in the existing websites and compressed approximately 8 to 9 websites, and all are kept in one cloud. So data ownership is of now the data ownership is of only government of Maharashtra. Earlier it was not there. So at that time also I did the work of it's one of the good work I did in tribal development department. And one more thing, in tribal development department we get some extended help hands as well. Governments for tribal students, government we get the permission for the hostels as well, and the funds to the CIDCOs as already given in 2014, and one fund is given to the approximately it's a 59-69 lakh for the properties in Mumbai city. One in New Mumbai and both are in Navi Mumbai, even Dhansole and Koperkerne. But due to some reasons, the properties are not on name of to the government. It's still with CIDCO or some other issues are there. in my tenure with tribal development department, I got that opportunity and registration completed onto the government through the proper channel, and that activity also I did in tribal development department as well. So this is not a part of planning as well, but you need to do the lot of other activities as well in administrative point of view. Here the in district agencies, you are the responsible for each and everything. As a HOD, your phone must be always on each and every time, and a lot of opportunities and challenging work is here. Definitely the backbone is North Maharashtra University. Sirs properly groomed us, madam, and Mahala madam also was there for she was I met her only, and other staff as well. Just a minute. Huh? In market research as well, especially in market data, regression analysis, factor, cluster, and segmentation, branding, category branding. So these are the basic tools are also used. Some SPSS certification also I did in my tenure over there in AC Nielsen and TCS. So it was really very good opportunity as well, especially data validation and data preparation. And after that, you need to run the programs or do the coding for to the table generation and count generation as per to the client demand. Is really great and challenging work as well. And one more thing, I still remember when I was a student. That time, the from in front of our computer lab, there is a one statement or slogan is there: "Be satisfied what you have, never be satisfied what you are." I still remember because of those lines and environment I got get in the North Maharashtra University. Because of that, we are here. I suppose now I will stop here, and if there are any question or answer, or over to ma'am. Thank you.
Yes, thank you, Murray sir. Yes, any of the participant want to ask questions or anything else? Participants, please. Yes. You can even put your question in chat box.
And you can call me as well anytime, no worries. No problem. Thank you, ma'am.
Okay, thank you, Murray sir, for having fantastic information about the work culture in government sector. And I hope that the students might have got a lot of information and they might have noted some information from your presentation. So right now we'll move to the next part of our program. I request Mr. Manoj Patil to introduce the next speaker, Mr. Vishwaroop Mukherjee. Manoj Patil, sir.
Okay. Thank you, ma'am. I got this opportunity to introduce my friend Vishwaroop Mukherjee. He's working in a private sector since almost 14 years. He started his career from Nelson Then he joined IMRB for market research, and then absolute data research and analytics team. And now he's working as a machine learning trainer at TCS Kolkata. Believe me, he's a brilliant candidate. He continued his research along with his professional career. He's working on stochastic modeling and statistical modeling related with that market research data he's working on. He received many awards from various organizations, various conferences. Thank you, sir. Thank you, Vishwarup, sir, for accepting our invitation. Now I request
gratitude to all the organizers of our university, Professor Shinde, Professor R.L. Shinde, Dr. Kirti Kamalja, and Mr. Manoj Patil. I haven't met Mr. Koshti ever. I have heard about him from Mr. Manoj Patil. So today I will speak about let me share my screen. I have a very small presentation. Let me share my screen and then I will start speaking about it. So as Manoj already said, I have total experience of 14 years and mostly I have worked in R&D divisions where I have created some services and products. Mostly into marketing analytics, and that was in the initial part. Initial part of my career. So mostly into marketing analytics and retail analytics to a certain extent in in market research as well. And in the later part, say since last 6-7 years, I am mostly working on IoT-based data, Internet of Things based data in manufacturing and automobile sector mainly. Apart from that, I have worked on e-commerce as well. So these are the domains where I have applied analytics, applied statistics, machine learning, econometrics as well. As I mentioned, like I have mostly worked on R&D projects, and that is not the only thing.
Excuse me, Vishwarup sir. Excuse me.
Yeah, sure.
Yes. Yes. Now it is visible. You just make it full screen.
Is it visible now? Are you able to see my slides now?
Yes. Yes. Just
Okay.
make it full screen. Yes. Now it is okay. Fine. Continue.
Okay. Thank you. Thank you. So what I will try to speak about today, is about how this field of statistics emerged over time, and I will talk a little bit about machine learning. So I hope that in classical statistics, the courses we do, at least when I was there, when I did my master's in statistics, so machine learning, this part was not that much evolved. And nowadays people speak a lot of, speak these sort of jargons like machine learning, deep learning, artificial intelligence, and many people actually use these things. Many people do not use these things, but they like saying these sort of things. Okay, so I will try to start from statistics and how this field, I mean, why do we need machine learning? What are the differences? What differences are there? So I will discuss on those. Okay. So before I get into those things, I will a little bit talk about Professor Prasanta Chandra Mahalanobis, whose birthday is today. And I mean, we all pay tribute to him. He is commonly known as father of Indian statistics. So I hope that you all know, all the students who are here, you all know that father of statistics. I mean, we refer Sir Ronald Fisher as father of statistics globally. In case of Indian statistics, we call Professor Mahalanobis as father of Indian statistics. Okay. So Mahalanobis, he completed his graduation from Presidency College, Kolkata. In those years, it was Calcutta in 1911. And soon after that, he went to London. He wanted to get admission in University of London. And he missed a train. And after missing that train, he was there. I mean, he reached England, but he had to take a train, which he missed, and then he took admission in King's College, which is again a quite famous college. And his subjects were physics and natural sciences. So in those years, after he completed his master's there, he had to travel back to India, and while doing that, he again got delayed because of some cancellation of travel. I mean, the mode of travel. I don't know exactly whether he was traveling by ship or traveling by aeroplane. That I don't know. In those years, people used to do international travel by ships usually. So there was a delay because of First World War, and due to that delay, he spent his time in the library of King's College, and then he read some books of statistics, especially the famous journal Biometrica, and he got very much interested on that, on this subject. So earlier also during his course, he would have read some statistical stuff, but after reading some articles, he got more inclined, more interested on that. And gradually he decided to work on statistics and apply statistics for human welfare and development of India. Gradually those sort of things he started thinking about. And he was encouraged by a philosopher called Brajendranath Seal, and eminent writer and poet Rabindranath Tagore. He was encouraged by both of these eminent people for studying statistics. And so he returned to India, and then he started working on anthropology. I mean, applying statistics on anthropological studies. Okay. So by studying different communities, their health and different things, he started studying by applying statistics. And that is the time when he developed famous Mahalanobis D-square. Okay. Apart from that, Mahalanobis worked on agriculture. He had significant contribution on sample survey, and not only Professor Mahalanobis. In India, if you look at Indian statisticians, I mean, if you think about Indian statisticians their contributions in the whole field of probability and statistics, there is a big contribution in the field of sample survey. So many people say that, I mean, there is a difference in opinions about the first computer which was installed in India. So there was another computer which was installed in Tata Institute of Fundamental Research in Mumbai, more or less in same time. I don't know exactly the timing, so maybe a little bit before or a little bit later. So computer was very much new for the whole world in those years, and of course for India, a developing country like India. And so in those years, many people, many eminent leaders around the world, they had visited Indian Statistical Institute. I am talking about leaders, not statisticians, probabilists, or mathematicians. I mean, national leaders, many big national leaders from different countries. They visited Calcutta and to see how sample survey work is being done using computer. Okay, so it was like that much big sensation in those years. And so two statements, two quotes here you can see. One is from Harold Hotelling. You know Harold Hotelling, right? You would have learned Hotelling T-square, especially the students who are in masters. I think some students are there who are from the bachelor's programs also. So especially the students who are from masters, you have studied Hotelling T-square, the relationship between Hotelling T-square and Mahalanobis D-square and all these things, right? So you can see like there is a big accolade from Harold Hotelling, who said that no technique of random sample has so far as I can find been developed in United States or elsewhere, means United States, Europe, or I mean the whole world practically, which can compare in accuracy with that described by Professor Mahalanobis. So there, I mean Mahalanobis and his group's work in sample survey was so much internationally acclaimed. Sir R.A. Fisher, who is known as father of statistics, his compliment you can see here. He said that I mean his compliment is especially about the Institute ISI, that the ISI has taken the lead in the original development of the technique of sample surveys, the most potent fact-finding process available to the administration. When it comes to administration, many of us already know that Prasanta Chandra Mahalanobis was an important part of Planning Commission of India, and he had crucial roles in the first and second 5 years plan, especially the second 5-year plan. And in fact, I mean, as a person, as a planner, he was appreciated by some leaders who had visited India in those years. I mean, they had open appreciations in front of media, in front of Pandit Jawaharlal Nehru. So such things are there if we browse through history. So sample survey was, I mean, after India got independence, ISI was established before independence, but it started flourishing after independence. And after India got independence, India being a underdeveloped country and so on, so considering those things, so we had lot of scope of application of statistics, a lot of need rather. Okay, we needed statistics a lot for developing our nation, and that was being done by leadership of our government, our ministers. So there is a Professor P.V. Sukhatme, who I mean, I think you would have read some book on sample survey by P.V. Sukhatme. So he was initially interested about probability. He possibly wanted to be a probabilist, and he spoke about these concepts of probability with Sardar Vallabhbhai Patel. And Sardar Vallabhbhai Patel, at that point of time, he wanted to understand like how probability can help India, can help our nation in nation building. So Sukhatme was not possibly able to answer that very well, and then he realized that I mean, we lack many data, many information what we should have. We do not have such many informations about our country, and then he started working on sample survey. So so as I said, like in sample survey, I mean, that was the need of the hour in those years. So we cannot compare how India is today and how India was in those years, some 50, 60, 70 years back. I mean, there was a big difference. So we didn't have much information about our own country, about poverty, about income levels, about even population of different areas, different states, and different things. Like, so we didn't have much information. So statistics was very much necessary, and accordingly that kept on evolving. History of statistics in India, I came across two interesting papers where you can learn more history, more about history of statistics in India. One is by Professor B.L.S. Prakasha Rao, who is a legend in our field. And the other one is by Professor Jayanto Kumar Ghosh and others, another legend, especially in Bayesian statistics. So these papers you can jot down, or maybe you can feel free to take a screenshot of this slide. So if you are interested in learning how statistics evolved in India, you can go through these two papers. Maybe some more literatures are there which I am not aware of, but and in these two papers actually it starts from how statistics, how census, how data collections that happened in ancient India, okay, say in 500 before Christ, so some 2500 or 2600 years back from today. So I mean, this history of statistics starts from there. History of data science starts from there. So this is in brief about history, especially about Professor Mahalanobis, whose birthday is today, whose birth anniversary is today. Now I will move to how statistics, I mean, we all know that statistics is applied a lot in industry and in almost all domains. Okay, it can be banking, it can be retail, it can be marketing analytics, it can be manufacturing, it can be automobiles. So everywhere, it can be healthcare. Okay, so all these fields, I mean, everywhere we apply statistics, right? So I mean, I am not aware about any domain, any field where statistics is not applied. Okay, so I'm not getting into that, like what all applications are there. We all know those things, or simply like doing some internet searches also can give us more ideas about applications, more informations and ideas about applications. So what I will try to discuss, like how it has changed over time. Okay, so this is pardon me. So statistics, as we have studied, I mean, when we study statistics from the very basic level, we talk about population, we talk about samples, we talk about like how to get a good sample, get a sample which is a good representative of the population, and all these things we talk about. With there are different strategies like stratified sampling, and different strategies are there, right? Different sampling strategies are there. So we do all these things, and based on the sample, what we do, we try to estimate some parameter, right? So we try to calculate some statistic which is calculated on the sample observations, and we use that statistic to estimate value of the parameter which nobody knows. So why do we do that? We do that, I mean, the very much practical reason is we cannot do complete enumeration. We cannot do a census kind of thing. Even if like the census happens in India or any other country, so where we do complete enumeration, we count each and every people, we ask their education level, we ask their age, gender, different parameters we try to capture, but is it really foolproof? So we definitely miss out many people as well, right? So, I mean, not missing out is something like unimaginable in census, actually, especially in such a big country. So, and now if I consider the population to be, say, things being manufactured from a factory. So a factory has, suppose, 100 machines, and all those 100 machines are producing same thing. So every hour, 1,000 items are being produced per machine. So I mean, millions of items are being produced every day. So I mean, here the population is an infinite and continuously increasing population because the factory is running continuously, right? Or I mean, so it's a continuously increasing population. So we practically cannot do a population study. We cannot measure, say, think about in a quality control, statistical quality control problem. So we have defined a quality characteristic, say length of a pen or diameter of a pen, okay? And we are using, suppose, sensors and all to measure those modern technologies we are using, that is fine, but still we cannot measure the whole population. We cannot measure quality characteristic of the whole population, right? Because the population is infinite, it is continuously increasing. So ultimately I mean, whatever we are using, big data or not, practically in most of the cases we are using sample. We are doing our analysis on sample itself, not on anything else, okay? Sorry. So now okay, so let me go back to the topic what I was talking about. So how it has changed over time. So nowadays we hear a lot about statistical, I mean, machine learning or statistical learning, okay? And I'm not getting into the parts called of deep learning, artificial intelligence, okay? So for the sake of time, I cannot go through those things. I would not like to discuss on those things. And for machine learning also, definitely I cannot discuss all theories and practicals and all those things. So that is not possible in a session. So what I am trying to say, like, why, I mean, how this subject changed, why do we need machine learning, and what extra things are there in machine learning, okay? So machine learning techniques were mostly invented during 1980s, late 1980s or early 1990s. The basic machine learning techniques were developed. The fundamental was developed during those years, late 1980s or early 1990s, okay? So the eminent people who developed, who published papers on such techniques were Leo Brayman of California University, Berkeley, Jerome Friedman of Stanford University, and in fact, the term machine learning was coined by Tom Michel even way before, I mean, long before that, possibly in 1960s. But what they could not do, Brayman, Friedman, all these people are basically statisticians. So what they could not do, they published their papers. I mean, they conceptualized machine learning. They published their papers and they applied their concept on a small data set. Okay, but in those years, computational facilities were not so strong. We didn't have very advanced computers which can compute a lot of things in a fraction of a second, or I mean in less time. So the computational facilities were not as strong as we have today. So though those techniques were invented way back way back in 1980s and 1990s, people couldn't apply those on real data sets. Okay, so they published paper, they conceptualized those things, they proved whatever they stated, and also they applied what they had, their concepts on some small data sets, but practical application on real data sets were not very common, were rather very, very uncommon, because those things required intensive computation. Okay, so nowadays what happened since say last decade or a bit more than that, machine learning gradually has become popular because of the progress in computation. Our computers I mean, we have, I mean, efficiency of computers have progressed a lot, and that is the main reason I mean, that enabled people to apply machine learning techniques on to solve real problems. Okay, so what is difference in machine learning techniques? So what I feel that mainly two things. I mean, machine learning is a vast subject like statistics, and machine learning is standing on the subject statistics. I mean, the base is of course statistics. All the base learners we talk about are coming from statistics, like logistic regression, linear regression. So these are we call the base learners decision trees. So these are coming from statistics. What is done in the new approach is I mean, the parameter estimation process is a bit different. The optimization, so here what we do, we try to find out, I mean, we built a loss function and we try to minimize that loss function. So earlier, if you think like if I use pen and paper for minimizing, for getting the minima or maxima of a function, I need to do differentiation, right? So I need to take help of differential calculus. But in computation, when you use some software or some programming language, usually the source code, which is there, I mean, we often use one particular command in R or one particular keyword we use in R or Python or SAS, okay? But if you look at the source code, so earlier we used to use optimization methods mostly from the numerical analysis field, and nowadays we use some advanced optimization methods to get to minimize loss function, to get the minima of the loss function, and so on. And accordingly, after getting that, we consider the corresponding parameters. Okay, so please let me know if it is sounding a little bit theoretical, and if you are not able to grasp anything, you can ask me questions. So that is what is done, that is what is different in machine learning. And in any practical projects, so I mean, when this machine learning, data science, these terms were not so popular, say 6-7 years back, or a bit more than that, maybe. I'm sorry. So maybe 8 years back, okay? So when these machine learning and data science, these terms were not so popular, then also, sorry for the disturbance. Then also what we used to do, suppose, let us consider a problem. We need to predict loan default, okay? We are doing analytics in a bank, and we have to come up with a model to predict probability of loan default, okay? And accordingly, so what we will do, we will create a model based on the historical data. We will take historical data where we will have a set of independent variables, and we will have their record, whether those people defaulted their loan or repaid their loan, and that whether they defaulted or repaid, that can be taken as a binary variable. That is the target variable, that is the dependent variable, and we will run some model, okay, run some statistical technique and create a model. So say we have run a decision tree or maybe logistic regression, okay, we will do something, and we will get a model, and we will apply that model on the new data set, right? So when we apply that model on the new data set, it means that when people will apply for loan, the new people who are applying for loan in our bank, we will be applying that model on the information we have for that particular customer, that particular applicant, and we will get probability of default for that person, okay? So based on that probability of default, we will take decision about whether to disburse loan to that person or not, and if we decide to disburse loan, then what would be the amount, okay? So that is what I mean, that is a typical project, right? So you can think about similar projects in other sectors also, like say machine failure in manufacturing, engine failure in automobiles, in aviation, okay? So everywhere similar approaches are taken. So we prepare a model on the historical data set, we apply that on the new data set, right? Now, while preparing the model, when we do not have any new data set, so when preparing the model, what we do, we divide the data in two parts or often in three parts, right? So in one part of the data, we train the model and then we test it on the remaining part. So that is also part of the historical data basically. But in the one part, say 70-30 is the ratio by which we have divided the data set. So we would be training the data, training the model on the 70% of the data, and we will apply that on the holdout set of 30%. And we will see how good or bad our model is performing. So that is one easy way of testing our model. So apart from that, different ways are there, different validation methods are there. So I think you would have learned some of the methods like k-fold cross validation, leave one out cross validation. So this sort of different methods are there. Okay. So now, while training our model, we use a statistical technique, or we use different techniques, and then we go by some model selection methods and find out which one is the best model. Maybe I can try discriminant analysis, maybe I can try logistic regression, and then I will see like which one is doing better. In machine learning, we use such techniques, such basic techniques, such statistical techniques as the base learners. We call these as learners, okay? And what we do, we run such techniques repeatedly, either on same sample again and again. I will explain that later. Or we draw different samples and run same technique on different samples again and again. Okay, I will discuss in this in more detail, but not very much, because these are itself a big concepts. Okay, so these are called ensemble learning, ensemble-based learnings. So two widely used ensemble-based learnings are bagging and boosting, which are umbrella kind of techniques. So different kinds of bagging can happen. Different kinds of boostings can happen, especially. So these are some tricks we apply, some smart tricks we apply on the statistical techniques, and we call it machine learning. Okay, so what are the advantages? I will talk about those. Before I get into that, what is the benefit of using larger sample? So can anybody, any student ping me on the chat box and tell me like what is the benefit of using a larger sample in terms of statistical terms? Can anybody answer this? I'm asking this to all the students who are attending. Yeah, so less error, more accuracy. Yeah, of course. Yeah, so those are all correct answers. So what happens? Which property? What is the property we have of estimators, which says that larger sample is the better thing? What is the property? Okay, so are you aware of the property called consistency? So when we define a good estimator, there is a property called consistency, right? What does a consistent estimator mean? A consistent estimator says that if you are using, if your parameter is theta and if your estimator is t, then the difference, the absolute difference between t minus theta will tend to 0 as your sample size tends to infinity, right? It can be written using notations of limit and all, right? Using the calculus notations of limit. So it can be written using those notations. So it says that if theta is your parameter, which God knows, and t is the estimator you have taken, which you have calculated based on your sample survey, then what is the error? The t minus theta is the error, right? So that converges to 0 as n tends to infinity. N is your sample size, right? So bigger the data, better it is. We will less probability will be there of committing error. Okay, so if the I mean, if we consider a particular constant or a interval, say what is the probability that the error will lie between delta 1 and delta 2, where this delta 1 and delta 2 are two numbers, we have made an interval. So what is the probability that absolute error will lie between this interval? That probability we will have, that probability will decrease as sample size increases if the estimator is a consistent estimator, right? So that is an important property of a good estimator. So that is the reason we say that bigger the data, better we will be in a better position to estimate, right? So of course there is a big advantage if we are able to analyze a large data set. Okay, so a bigger size of sample, and nowadays there is a term called big data. So that is the reason, big data we use as a term. So it means a huge data in terms of, memory space it occupies. It can be terabyte, it can be petabyte. Okay, so it would be a big data. Okay, so essentially what it means that it contains many number of observations. Okay, so the whole subject statistics is about what? Statistics is about studying the population based on a sample, right? You have a population, studying the whole population is practically very difficult. It's not something pragmatic, and that's the reason we are drawing some sample. We will draw some sample, and using the sample we will get some information about the population. And that is the reason when we do such things, when we draw some inference about the when we draw some study the population based on the sample, the estimates we do have some standard errors also. So theoretically, if we are not doing sample, not doing our study or not doing our analysis on the sample, and instead of that, if we are doing our analysis on the whole population, then what will happen? Then standard error of the parameter estimates will be zero. We will get the parameters itself, right? The estimates, the estimators will estimate the parameter without any error, right? So that is the advantage. Now, practically, though we use big data, say in Internet of Things. So if people, if you do not know what is meant by Internet of Things, Internet of Things is, is a term which is used for systems from where we can, the systems and the data, systems where different sensors are there from which we can collect data. Okay, sensors or different things are there from where we can source data. Okay, so you can consider, say, your mobile phone and the data, like how much time you keep your mobile phone on, how much time you play music, how much time you watch videos, how much time you call, how much time you spend in some other apps. So all these things can be captured, and if those things are captured, the corresponding data would be an IoT based data, Internet of Things based data. Okay, so Internet of Things based data can be captured on real time or maybe on near real time, and this is the such data are usually very big in size. Okay, so data, when we talk about data, size of the data, we it can be thought in two ways. One, in a structured data, how many number of rows are there and how many number of columns are there. Okay, so that is one thing. And in total, how much memory it is taking, okay, in terms of gigabyte or terabyte or petabyte, okay, how much memory it is taking. So that is also how we define size of the data. So even if we are collecting Internet of IoT based data of all the, suppose we are say, think about the engines of an aircraft. Okay, so we have sensors fitted on the aircraft which keeps on measuring temperature, pressure of different components of the engine which is there in the aircraft, in the aeroplane. And what we are doing, we are collecting all this data in an automated mechanism. Okay, so that is an IoT based data, or maybe a telematics data we would call it. So can we say that that is the whole sample? Yes, that that is the whole population. Can we say that? Yes, that is the whole population if we define a particular time period, that from this date, from to that date, some say 1st of June, 12 o'clock in the midnight, to 30th of June, 12 o'clock in the midnight. If I collect data, that is the whole population, because I have all observations, no sampling is done. But is that really a population? That is not, right? Because multiple aeroplanes of same model, same manufacturer, same make are flying across the world with different, aging, different, the aging of those aircrafts also can matter. So differences are there. Those aircrafts are flying in different climatic zones, and all those things are there. So different things are there. So if a aircraft is flying over India, and if a aircraft is flying for the same model is flying over, say, northern part of Canada, okay, so the temperature in different components in the engine can be different, right? Because the climate of these two places are different. So all these things we need to consider. And even if I do not consider all these extraneous variables, even if we do not consider all these extraneous variables, then also the IoT based data I have collected may not be the whole population. That is highly likely. It is highly likely that this is not the whole population, because this is not the whole data set. Okay, so if I do some analysis on data that I have collected from one particular aircraft, or maybe suppose I have done some tie-up with Indigo, and I have done some study. I have collected their data of their engines, of their Airbus 320 aircrafts, and I have that data, okay, for 1 month. So that is essentially a very big data that would be, because different sensors have produced data. Some sensor will produce data once every second, some sensor will produce data once every minute, and so on. But still, that is not the whole population. That is not the whole data, because Indigo is not the only aircraft which uses Airbus 320. Okay, so that is not the whole data. And also it is not so from the time horizon. Also it is not so that they have used that particular aircraft, that particular set of aircraft on the month of June 2021. They have been using it since long, and they would be using it in future also. So this is actually an infinite data set, and most importantly, this is continuously increasing data set. So whatever big data we have collected is practically a sample, not a population. And that is the reason whenever we are applying any statistical or machine learning algorithm on that data set, since the size of the data is big, it is expected that we will have better estimates, better inferences we will be able to draw, but some extent of standard errors will be there, right? Some scope of standard error would be there, because the data is not of the whole population. And also many features would be there which we would not consider, right? In regression, what happens if we suppose you have run a regression with 4 independent variables? So you will have some error. You include one more variable, you will have less error, right? So many variables are there, many features are there which we could not capture, so we could not use as independent variables. So that is also there. Despite of progress in technology, it is not so that we are able to capture each and everything. Okay, so anyway, so advantages of analyzing big data I spoke about from at the very beginning, that bigger data gives us enables us for doing better analysis, doing better estimates, getting better estimates and all. Now, how this has become possible in these in recent years, because we have developed a lot in terms of computation, computational facilities. In terms of data warehousing, we are able to keep and manage data better, manage bigger data better. We can store data and retrieve data as required. So this has become easier in recent years. And also the other thing is we have systems, we have cloud computing, we have like the Hadoop ecosystem. So we have, I don't want to get into a lot of technical stuff. So we have such things where we can, which we can use to do processing of our data, processing of our big data. Okay. So these are some developments that has happened. The other thing is we have cloud-based platforms like Google Cloud Platform, Amazon AWS, Microsoft Azure, where we can do analysis, we can run algorithms much faster. And usually these cloud-based platforms have some inherent advantages, like based on our requirement, they will add random access memory, they will add cores. Okay, so suppose suppose we are running it at 8 core, based on the requirement, it can be increased to 16 core. So this can happen dynamically without investing a lot of money for setting up such a developed computer in my office or in my university. Okay, so these are some technological advancement that has taken place in recent years, which has enabled us for analyzing big data. That is one part, and also for applying algorithms which needs computationally intensive, iterations. Okay, so algorithms which need multiple iterations, which are computationally intensive, that can be done easily. Okay, so two aspects are there. One, applying whatever we are doing, be it something very simple like linear regression or logistic regression. It enables us for doing something on big data sets, huge data sets. This computational advancement that has enabled us to do so. And also it has enabled us to apply computationally intensive algorithms on such data sets. Okay, so the disadvantage Brayman and Friedman had faced during 1980s and 1990s and many others, those disadvantages are not there, or maybe like we will progress further, and our computational speed will increase further in coming years. So those disadvantages are not there today. So that is the reason we are able to use such techniques. But anyway, such techniques are based on the base learners, which are coming from statistics. Okay. So the other big advantage is about real-time analytics. So earlier, while working on projects, the practice was like we will have some historical data, we will do analysis on that, we will come up with some model, and we will apply that on new observations. That will keep on happening for 3 months or 6 months or even 1 year. Okay. So let me go back to an example of, say, engine failure. Okay, in aviation. So what we will do, we will collect historical data, we will create a model, and we will apply that on new data sets to predict failure of engine. So if I find that probability of engine failure is very high on a particular time point, then what will happen? I will raise flag and ask pilot to ground the aircraft as soon as possible, okay, to avoid any kind of accident. So now these engines are like mechanical things, right? Mechanical and electronic things. They do not have intelligence per se. But think about credit default, okay? So think about loan default. So those are being done by human beings who are intelligent, okay? So if I prepare a model based on some historical data of credit default that has happened in my bank, and at the same time, many people had repaid loans as well. So if I use that historical data and come up with a model, and apply that model on new applicants, then what will happen? Initially, it may be possible that I am doing very well. Okay, I am very well. I am able to decline loans applications where I mean, who are real. I mean, where I feel that not feel the. I mean, where really the likelihood of defaulting the loan is very high. Okay, probability of defaulting the loan is very high. So we are initially, after applying that, I mean, we might get very good results. But over time, what will happen? Over time, human behavior might change intentionally or unintentionally. So people who do fraud, they might change their strategy. They might do something to fool my model. Okay, they will. They might say location or age or maybe income level. So they will manufacture some records, and so that my model says that this person is has very low probability of defaulting my loan. So, I mean, people who are going to do fraud intentionally, they can do that. Unintentionally also, human behavior can change. It can happen in machineries also. So different times due to wear and tear. So relationship among independent variables, relationship with independent variable and the dependent variable, all these things, these patterns might change. So we need to have something dynamic. Okay, we need to have create model dynamically. So what is done in machine learning, when we apply machine learning in the real sense, what is done, it will consider dynamically, say, data of last 3 months and create a model and apply that. After 1 day passes, or maybe after 1 week passes, it will discard the data. So the whole data is of 3 months, say 12 weeks. So it will discard the oldest week from the data set, and it will include the newest week in the historical data set and create a new model, which will be a little bit different from the previous one, right? And so what is happening? I do not have to wait for 6 months and then again do a project and then again come up with a new model, because my bank has incurred losses for loan defaults, okay, in the later part of the 6 months, okay? So that I do not have to do. It is happening automatically and dynamically. So this is the other benefit of applying machine learning. In fact, that is the real application of machine learning. If we are not able to do that, then we are possibly using advanced techniques, but we are not learning along with the emergence of the data, along with the evolvement of the data, okay, or evolvement of the pattern. So I already spoke about this loss function optimization. So there is a common technique, a very widely used technique called gradient descent in machine learning, which is an optimization technique which is applied on loss function to get the minimum value of loss function. And gradient descent is very much efficient. And one other big advantage of gradient descent is, when we apply gradient descent on the training data set, we see that it will start converging to the minima gradually, and if we are able to visualize that. But after coming closer to the minima, it will kind of hover around the minima. It will not hit the exact minima very easily, okay? So apparently it might look like a disadvantage, that it is not, initially it converged very fast towards the minima, but after coming quite closer to the minima, it is not hitting the exact minima and it is hovering around that, okay? So apparently it is a disadvantage, but it is not a disadvantage, and it is a very big advantage. On training data, if it hits the minima, then we will get a model which would fit almost perfectly or perfectly on the training data set. And that will cause problem of overfitting. Overfitting you would have learned in, I think you would have learned during your programs, master's programs. So overfitting is a typical problem where you get a model which fits very well on the training data, but when that model is applied on the test data set on the new data set, it fails miserably. Why that happens? Because it captures randomness also. Okay, it models randomness also. It creates a complicated model which captures randomness. So when you apply such a model on the new data set, it fails miserably. Okay, so in terms of machine learning, we use two other terms, supervised learning and unsupervised learning. So unsupervised, let me talk about unsupervised learning first. So unsupervised learning is a problem where we do not have a target variable. We do not have any dependent variable. Suppose we have a set of variables, say think about different features, different physical things, like say, if we do blood test, different measures of blood. Okay, it can be cholesterol, triglyceride, SGPT, SGOT, hemoglobin. So different measures are there, and using those variables, those are all continuous variables, I assume. And using those variables, if I want to club similar kind of people, okay, or people having similar kind of health, so ultimately what I am trying to do, I am trying to get some groups of people. So that is the problem of unsupervised learning. We do not have any target variable, any dependent variable here. So k-means cluster analysis, hierarchical cluster analysis, and these are some basic techniques. Some model-based techniques are also there, like mixture model-based cluster analysis. Okay, so where we assume some probability distributions which are there in the we assume that the population we have got, or the sample we are using, which is representing the population, is coming from a mixture distribution, mixture of different probability distribution, and we run some algorithm to find out those different probability distributions, which essentially gives us different groups. Okay, so different techniques are there. Many other techniques are also there from deep learning also. Okay, supervised learning is the set of techniques where we have a target variable, where we have a dependent variable. So for example, the binary dependent variable I cited, like whether the loan was defaulted or repaid. Okay, so whether the engine failed or not. So whether a person is going to buy one particular item or not. Okay, so in a problem of retail analytics or marketing analytics, whether a person is going to respond positively to a campaign or not. Okay, in campaign analytics. So this sort of things are there. So these are all supervised examples of supervised learning, and all the examples I cited just now are they have target variable which are binary, right, which are categorical target variables. So not necessarily it has to be binary, it has to it can have more number of categories, more than 2 number of categories. So in such problems, we call it classification problems. Such problems of supervised learning are called classification problems. Okay, so what we do, we classify an observation to one of the classes, like loan default or loan repay. Okay, so loan default is a class, loan repay is a class. We try to classify one particular observation in one of these classes. 2 or more classes we can have based on the values we have in the independent variables, in the explanatory variables. Okay, so these sort of problems are called classification problems. The other kind of problems in supervised learning will have target variable, will have continuous variable as the target variable. Okay, so for example, in agriculture, like yield. So if we consider say we are cultivating wheat. Okay, and we have taken measures of salt, different kinds of salts in the soil, rainfall. All these things are my independent variables, and I'm trying to estimate how much yield is going to happen, in how much harvest I am going to get, and I'm measuring it in terms of kilograms. Okay, so it can be considered as a continuous target variable. Okay, so such kind of problems are also of supervised learning, and these are called regression type problems. Fine. So these are some broad classes of problems of machine learning: supervised learning, unsupervised learning. Within supervised learning, classification and regression types. One example I forgot to cite you while talking about this real-time analytics. Say, think about pricing, think about the e-commerce portals. Okay, so it can be a travel portal, right? Say like say Make My Trip, Yatra, okay, or it can be some e-commerce portal like Amazon, Flipkart. So you would see that pricing. So earlier what people used to do, people to price a product, suppose Coca-Cola or any other company, suppose that company has come up with a new product, okay, now they want to get the right price for that product, okay. So there were different methods of doing the price, for doing pricing of that product. So people will do some market research. People ask people, interviewers will ask different people about what can be the price of this thing, at which price you will buy. So there is a different schema of asking different, asking some questions, and accordingly, different analysis will be done, and people will, and the organization and the company will decide upon pricing of that newly launched product, okay, or maybe the existing product. They can change their price also. But nowadays, what happens in e-commerce portals, okay, so it can be any e-commerce, okay. What happens, we see that prices are often changed very much dynamically, especially if you see portals, the travel portals like Yatra, Make My Trip, Go. So there you will see that price of flights change very frequently, okay. So I don't want to take example of any of the companies. I just I don't know what tricks or what techniques they use for pricing and all, specifically for these companies. I just cited some examples, but in general, what is necessary is we need to take decisions very fast. We cannot do a survey or we cannot do a study. We take our sweet time of 1 month, then come back with a recommended price, and then decide to use that price and launch that product on that price we have decided upon. That much time we do not have in e-commerce. So there, what we need real-time analytics or near real-time analytics, okay. So it will consider like at which time, suppose that can be a way, it can consider like at which price people are buying that product more. So what is the rate at which people are buying one particular product? What happens if I reduce that price? Does that rate increases, or does that rate doesn't, remains more or less same, okay. So all these things can be considered, and dynamic pricing can be done. Anyway, it can consider, maybe we can consider competitors pricing also. Okay, so as I said, like ensemble, so there are two main buckets, two main umbrella of techniques called bagging and boosting. Apart from this bagging and boosting, also we have some other ensemble mechanisms, and also some other machine learning, rather many machine learning techniques are there, but bagging and boosting are the two major umbrella of ensemble mechanisms. So I will discuss it very briefly. So this word bagging is coming from two words, bootstrap and aggregating, okay. This bootstrap and aggregating, these two words are abbreviated kind of to create the term bagging, okay. So bootstrap was developed by legendary statistician Bradley Efron, and Leo Breman first published his paper on bagging in 1994, okay. So as I said, like most of the fundamental developments of machine learning happened by statisticians during 1980s and 1990s, okay. So Leo Breman also did this development of bagging in 1994, you can see early 1990s, and Leo Breman has significant contribution in machine learning. So he was able to apply his concept, the idea he developed on some data sets, but after that, people bagging was not so common in practical applications because it required, I mean, it is computationally intensive and computer facilities, our computers were not that much efficient in those years. Okay. So what it does, we have a sample, assume that we have a sample. We will draw multiple samples from that sample we have. So we will draw practically subsamples from the sample we have. Okay. And the method would be simple random sampling with replacement. That is the basic of classical bootstrap, right? So with replacement. So that is how we will draw multiple samples, say 100 or 500 or 1000 samples we will draw. And we will run one particular base learner, say logistic regression, on that, or a decision tree on that, on each of those samples. Okay, separately on each of the 100 samples, we will run say decision tree on, and we have drawn say 100 samples. So we will apply decision tree on those samples separately. And then what we will do, we will aggregate the results. Okay, a common aggregation method is the voting method. So while classifying, so suppose we are classifying, we are trying to classify an observation, whether a person is going to default alone or not. Okay, let us go back to that problem. So what we will do, we will pass that observation through each of the decision trees. Suppose we had drawn 100 samples. So we had built 100 decision trees. We will pass that observation through 100 decision trees, and we will see, like, some of the decision trees will say this person is going to default a loan. Some decision trees will say this person is going to repay the loan. And we will go by a voting philosophy. We will see where the, I mean, what more number of decision trees are saying, and accordingly we will draw inference. And based on the number of decision trees which are saying and their corresponding probabilities also, we can come up with a composite probability measure also of default or of repay. Okay, so practically these two will add up to one: probability of default and probability of repayment. So this is the basic bagging. I am not getting into the complications. So there is a very commonly used technique called random forest, which is a bit different than bagging. Some improvements are there on random forest. So I'm not, I mean, for the sake of time, I mean, I cannot cover all those things in detail. And the other umbrella of ensemble techniques are boosting. Okay. So in boosting, what we do here also, we aggregate different models. Okay, like in bagging, we created 100 models. Suppose we drew 100 samples. So here also we will create multiple models and aggregate those. Okay, the basic models, the models which we are creating are called weak learners. Okay, and if we aggregate these weak learners, we ultimately get a strong learner, which has high degree of predictive accuracy. Okay, so there are different types of boosting. So the simplest type of boosting is called adaptive boosting. It was developed by Freund and Scaffier. I think it was also developed in 1990s only, and after that, gradient boosting, also known as GBM or gradient boost machine, was developed by Leo Bremen and Jerome Friedman in those years. I don't remember the exact years, but it would be some 30-40 years back only. So these techniques were developed in those years. So what boosting does, what adaptive boosting does, it will run a technique on the data set, and we will be able to classify some of the observations correctly. Some of the observations